My original plan was just let the fans run all the time, but I seem to be noticing fan noise more and more, not sure why. Now the two fans are not very loud, but at full speed they are very noticeable, and there doesn't seem to be any need to run them wide open, as long as the load is under 300 watts or thereabouts. Thing is, I only gave myself 2 lines to control the fans. That was before I decided the fan power was going to be connected to the power coming in, and hence isolated from the load terminals. Turns out one more line would have made things a bit easier. The fans are the Noctua NF-P12 1700 RPM. They came with the heat sinks, and it looks like they are very nice fans. Actually seem very quiet for the amount of air they move. They have a 4-pin PC connector on them, with a pretty short cable. So they have a PWM input to control the speed, and they have a tachometer output. The PWM signal to the fan needs to be around 25 kHz. And even though the fans run off of 12 volts, the PWM and tachometer signal are limited to 5 volts maximum. So at first I was planning on doing this. One optocoupler to turn the power to the fans on. The other optocoupler drives a buffer for the PWM signal to the fans. I almost started laying out a PC board for this, but I hated leaving that tachometer signal just lying there, going unused. I thought I've already got a 5-volt regulator, buffer, and associated parts to go with it. I could add a small microcontroller, wouldn't take up much more space, and add what, $1.50 to the cost? So I ended up with this. Now, one optocoupler receives a signal to the fan control board, and the other optocoupler transmits a signal from the fan control board. I had a PIC 16F1765, a couple of small MOSFETs, and a couple of Schottky diodes, and a few resistors. Maybe $1.50 extra of parts to get to tell if the fans are running. Well worth it, I think. At first I thought I would need to leave the 12-volt supply on all the time, but that is where the 2 small MOSFETs and diodes come in. When this line right here is pulled low, and by low I mean below about 0.6 volts, it will turn the 12-volt supply on, which will then power up the microcontroller. So this is the serial data from the main controller, and what starts up the 12-volt power. And this line is the serial data to the main controller. To start up the fans, this line from the main controller is brought low for about 100 milliseconds, which powers up the 12 volts, which in turn powers the 5 volts to the microcontroller. One of the first things the microcontroller does is turn on Q1, thereby keeping the 12 volts on regardless of the level of the data line from the main controller. Then it turns on Q2, which supplies 5 volts through a 2.2 k ohm resistor to what is this microcontroller's UART RX input line. After that, the microcontroller watches the RX input line for it to go high. Once it sees that, it turns on the UART's receiver and it's ready to receive commands. It will recognize a command to set the fan speed and a command to power itself down. That's all it needs to do. On the transmit side, it sends each fan's tachometer count per second back to the main control board. All I need to know is that the fans are running. That's it. Where to put the fan control board is what is going to determine its shape. I don't really want to extend the fan's leads, so that really limits where the fan control board can go. Right here, in between the mounting brackets for the heat sinks, there is plenty of room. The problem with this spot is that it's going to be very difficult to plug and unplug connectors. Here above the fans, I have plenty of length, but only about 0.9 inches of height. The great advantage of this location is the easy access to connectors. Above the fans was a pretty easy decision. A 3-inch long by 0.8-inch wide PC board gives plenty of space for the connectors and other parts. Even the 14-pin SOIC package for the microcontroller, which seemed so small when I bought them, but now it's like a huge space-wasting package, but very easy to use. I think I need a little temperature-controlled heat plate that I can place the PC board on to apply the solder paste. I heat it up with hot air, and at the start the board is too hot, and by the end the board is too cold. There is that just right temperature that the paste flows out, and makes a very nice little puddle. That's something I need to look into. This tube of solder paste is really getting pretty old. I do keep it refrigerated when I'm not using it, but if I remember correctly, it was supposed to have a 2-year shelf life, refrigerated, and I've had it over 5 years now, at least, and it still seems to work pretty good. Dispensing it on a room temperature PC board is very difficult, so that may have something to do with its age. But if its life can be extended by just heating up the PC board, that's not a problem, especially when you consider how expensive the stuff is. I'm still using tweezers to place the SMD parts. I did find the vacuum pickup station I bought, again, well over 5 years ago. I thought I would give it another try. It didn't work well when I got it, and being packed away for a few years didn't improve its usability whatsoever. I think the real problem with it is the air valve is just a hole drilled into the handle that you put your finger over. Vacuum pump is a little noisy, but I may see if I can do something with it, turn it into something that works. I do want to find something to help in placing the small SMD parts. This is still the most tedious part of building the PC board, and I think using tweezers is a large part of that tediousness. One thing that is not tedious now is using the hot air station. I do believe that with the age of the solder paste, it has lost some of its stickiness, so that adds a bit of difficulty. I think if my solder paste were in better shape, I could be even more aggressive with how close I get the hot air nozzle. Once the paste melts, can get right down on the part and they will stay in place. But still, it's just so much faster than soldering the parts with a soldering iron. I'm still just delighted with the hot air station. I will use a soldering iron to touch up any pads I was too light with the solder paste, but that won't take long. It's usually just a couple of pads. And I do think that if I could keep the board at just the right temperature, I could get the solder paste just about right on every pad. What I did not have on hand was a 4-pin PC fan header. I was a bit surprised at that. I found a couple of 3-pin headers that I must have pulled out of some old stuff, but no 4-pin. So I ordered a few of these when I ordered the optocouplers. I do like my connectors to look straight on the PC board, at least very close to straight. Well, I think that looks pretty good. Now to see if it works. Of course, the first thing I do is apply a low voltage at a very low current limit to make sure the voltage regulator is working. No shorts or over voltage, so that looks good. Definitely want to make sure the voltages are okay before plugging in the programmer. I just got this thing and I sure don't want to destroy it. I'm going to pick my spot where I want to mount it. It's basically about as far to the back as the front fan's leads will comfortably allow. I've still got to find some fan guards to go on this. I'm going to use one of the extra PC boards as a guide for the mounting holes. I'll just tape the board in place right where I want it. Get me a good spot started in both locations. Then slowly drill through the acrylic. This is not a bit made for acrylic, but at the same time, it's not very sharp. So if I go slow and careful, should be good. I'm close to the edge here, so I don't want to create a chip that in time can lead to a crack forming. Right now I'm just going to use these nylon spacers and 440 screws for mounting. As all of the regular 440 nuts I have are too large a diameter, I'm going to use these 440 posts as nuts. Once it cools down in the shop, I'll have to make a proper mounting bracket for it. But for now, this will work just fine. Really, this will work fine, as long as I don't have to remove the fan control board a lot. Here, I have the main control board programmed to do a slow ramp up and then a slow ramp down on the fans. The fans are very, very quiet till they get close to maximum speed, so I'm very glad I took the extra effort to implement the fan speed control. I'm sure I could run this at a 200 watt load and wouldn't even know the fans are running. Now for a bit of testing. I've got the one thermocouple on the heat pipe that runs right under the MOSFET, and the other is set to measure the air temperature coming off a heatsink. The room isn't quite that hot. I've had it running a bit already. If I figured correctly, the fan should come on at a little over 30 watts. Here I have it set to a 30 watt load. The blue, channel 2 trace, is the 12 volt supply. The red, channel 3 trace, is the fan PWM signal. Both channels are DC coupled and at 2 volts a division. So at 30 watts, the fans are completely off. The temperature of both feels about the same. I would say very slightly warm to the touch. The 30 watts, approximately 15 watts per heatsink, with no fans running, has maybe raised the temperature 5 degrees centigrade. It's quite a bit of heatsink for 30 watts, so I can probably up the minimum wattage for the fans to turn on. I'm going up to 31 watts now. Only one more watt, but this should turn the fans on. Now the signal looks like this. Of course, the 12 volts is now active. And this is about the minimum starting PWM that I will supply to the fans. I can barely feel the air moving at this level, and I can't hear the fans running, which I like. I'm going to 60 watts here. Still very little power for these heat sinks. The fans are running a little bit faster. I still can't hear them, but it's much easier to feel the air from them now. Let's move things up a bit, setting it on 200 watts. I've also moved the air temperature measurement to the front heatsink, same one I'm measuring the heat pipe temperature on, where I should have had it to start with. Now the fan PWM is about 2/3 on time. Fans are not really noticeable noise-wise. If it was a completely quiet room except for these two fans, I'm sure would be able to hear them run. The temperature is really staying low. I think I can take down my fan curve here quite a bit. At maybe a 9 or 10 degrees centigrade temperature rise now, that is way better than fine. I'm at 300 watts here. Should be just under maximum fan speed. Can see fans are almost at maximum. I can certainly hear them. About the same amount of noise as the fan in the power supply, so not bad. Temperature is still doing great, but I'm at almost maximum fan speed and only at half power for the load, so the temperature really should be great. But it does mean I can run the fan slower at 300 watts, for sure. But probably won't change that till I get the temperature monitoring set up. Have to protect those MOSFETs at all costs. I had to go to about 340 watts to get the fans at maximum. So here you can see the PWM control is at a solid 5 volts, same as it would be as if the fans were plugged into a 3-pin fan header. Again, the fans are not that loud, but they are very noticeable. I would say a bit louder than the fan in the power supply now, but not by much. So when I get the temperature monitoring set up, I think I will easily be able to use this at 300 watts without the fans making much noise at all. I'm happy with the fan setup now. I have the fan speed code to immediately ramp up the fan speed on an increase in load power, but it's set to take several seconds to ramp down the fan speed, which seems to work quite well. Once I get the temperature sensors in place, that will change how I operate the fans, and I think that is the next step. I won't really feel comfortable using it till I know the MOSFETs are not being destroyed. It occurred to me in doing this video that it's not just fan noise I notice more these days. It's a lot of really not that loud noises that I now notice. And I think the reason I'm noticing them is because of making these videos. Notice a noise in editing, and that makes me pay more attention when recording. And I think that just carries over into all the time. Not sure if that's a good thing or not. Should be good to notice more of what's going on around oneself. Yeah, I think so. Thank you for watching.